Right, so good evening, everyone. We'll be going through an example of a shell sort today. So before we begin proper, let's start with a brief description of what a shell sort is. A shell sort is basically an algorithm that is used to compare elements which are quite a distance apart from each other. By quite a distance, I mean that they are not adjacent to each other or they are not side by side to each other. Instead, they are relatively far away from each other. Okay, so since we are done with our brief description, let's move on to the actual shell sorting itself. Before we begin with any sort of sorting, we'll have to determine a gap size. Since we have 10 elements here, let's start with a nice gap size of 4. Since we have determined our gap size, we'll look at our first element here, which is 21. And then we'll skip 4 gaps to the right. 1, 2, 3, 4, which will give us 65. Now take note, we are trying to arrange this list into a descending order. So let's compare 65 and 21. Which is higher, which is lower? Obviously, 65 is a higher number than 21. So since in a descending order list, we want the higher numbers on the left, we'll move 65 to where 21 was. And we'll move 21 to where 65 was. Now moving downwards, we have 95 and 21. Since 95 is a higher number than 21, we obviously don't have to do anything here. Let's move downwards one more time to 94 and 73. Same goes, nothing much to do here. 71 and 71, they are the same number, so obviously nothing to do here at all. 21 and 81, very interesting. Since 81 is a higher number than 21, we will move 81 over to where 21 was and vice versa. One more time downwards, 21 and 86. Obviously, 86 is much higher than 21, so we'll move 86 to where 21 was and 21 to where 86 was. And this will be our final, I wouldn't say final, but this would be the product after we sorted with a gap size of 4. Moving onwards, we'll decrease the gap size down to 3. 1 minus 1 down to 3. So we'll look at the first element again, 65. 1, 2, 3, 71. Obviously descending order, so we'll want the higher numbers on the right, 71 and 65. Which one is higher? 71. Very good. So we'll move downwards, 65 and 86. Which one is higher? Obviously 86. So we'll exchange the position of these two. We'll get 86 here, 65 here. 86 and 73. Which one is much higher? Obviously 86, but 86 is already where it's supposed to be, so we will not touch this. 81 and 71, same thing. We will not touch this. 65 and 71. 71 is slightly higher than 65, so we'll exchange the position of these two to get 71 and 65 here, respectively. 73 and 21, nothing much to change. They're already in the correct order. 71 and 21, nothing much to change also. So we will conclude our gap size 3 here, and now we will move down by 1 gap size to gap size 2. Gap size 2, as you can see, there is nothing really much to change. If you can go ahead and pause the video and look at it for yourself, but to save you some time, I'll quickly run through gap size 2. So 95 and 86, 1, 2, same thing, nothing to change here. 1, 2, nothing to change here. Since 86 is higher than 81, 1, 2, nothing to change here too. 1, 2, nothing much to change. 1, 2, nothing much to change, so on and so forth. So we'll finally move down to the most detailed gap size, the most closest gap size of gap size 1. Gap size 1, this is the list of numbers that we were left off with after gap size 2. So let's compare closely, shall we? 95 and 86. They're correct, nothing much to change here. 86 and 86, obviously the same number, so nothing much to change here. 86 and 81, obviously the same. Obviously 86 is much higher than 81, so nothing to change here. 81 and 71, nothing much to change here too. 71 and 73, aha, okay. So we'll go ahead and exchange the position of these two together, 73 and 71. We've already determined that 73 is higher than 71, but okay, let's go ahead and look at the remaining numbers too, just to make sure. 71 and 65, obviously 71 is much higher than 65, so nothing much to change here too. 21 and 21, same number, so nothing much to change. So if you look here right now, the list has already been sorted in a descending order: 95, 86, 86, 81, 73, 71, 71, 65, 21, and finally 25. So this will conclude our shelf sorting algorithm. I hope this has been a good example of what a shelf sort algorithm is. Thank you.